Go ahead, Luke.
Basically, one person, like both parties, or how many parties would be content at being at whatever point this is, because if they move, they would be worse off.
Okay. So neither party wants to change their answer taking is given what the other one's done. Neither one wants to change, right? Assuming that the other one stays fixed with what they're doing. So that's kind of what we're getting at here with a unilateral decision, is that would one party want to change their answer, right? And then if they do, it's not a Nash equilibrium. Okay, so is the initial distribution a Nash equilibrium? What'd you guys get? No. Yes or no? I don't have the answers in front of me, so you can tell me the answer key. What does the answer say?
No.
No. Okay, and the most important part, why?
Because if one person could move, then they probably could.
Can you prove it?
So say one person could produce the cost at a lower, the other four would still have to be as part of this little thing. So it'd be 60 plus 100 plus 40. The other person say could produce it like $50 by themselves.
Okay.
Or by themselves, they can produce it at 70.
So by moving a little bit, they could do it?
Yeah, so let's say like they moved out of the way. With all 5 firms, the cost would be 110. And to say 4 of them are still there, then it'd be 100, and that one person's now just paying 70. So
Okay.
that person could be better off.
So since we have some fixed cost, then that would play a role into it, right?
Yeah.
On the quantity in terms of average cost. So the price of a product, average cost per test, each corporation in the region purchases 1 test per year from the product testing firm. All other inputs can go everywhere. Suppose 5 corporations are uniformly distributed, with 1 corporation in each city. So what picture in the book was this one? What picture in the book was this one? What figure? Anybody look back to their book when they were trying to answer this?
Yeah.
Usually none of these questions are like pulled out randomly out of the air. They were covered in here somewhere. And usually the book kind of goes in order, so the first questions would be more towards the front than in the back.
Yeah.
So this was the matching one. We kind of got profits going on with clusters. I didn't see the one I was thinking of, but I was thinking of the one we did earlier with the profits getting bigger if 2 firms combined with each other and the quantity goes up, what would happen to the cost? So we got a variable cost and fixed cost. Those of you have had some advanced classes, some of you haven't. What's the fixed cost with the firm here?
60.
60. How do you know that? Because there's no variable cost, or variable costs are what? How do you tell between a variable cost and a fixed cost in an equation?
Variable cost has to have a variable with it. So
It has the Q, right? The quantity, right? So the variable cost is those that change with quantity. Fixed costs don't change with quantity. So in an equation, if there's no Q in the expression, then that means that's our fixed cost. It doesn't matter if we produce 1,000 units or 100 units, we still have $60 of fixed costs. Okay, so that then kind of allows people to possibly combine or do something to lower their cost if their production doubles. Okay, describe the Nash equilibrium in terms of the distribution of firms and the price of a product test. What did you guys do for this one?
I plugged in 5 firms because each one's producing 1 product. At least that's what they tell us. Plug that into the formula, so 5 times the 10, and 2 plus the 60 gives you 110, and then you divide that by all firms, so 5 to give you which each firm.
Okay, come on up. This is where I do. Did you guys bring your copies of your work? You did. Okay. So did you bring yours, Luke?
I have that.
Is it handwritten with a picture? You typed it out? Because I've had people put their laptops on the document camera too. If we can see what you did.
I didn't do it.
Did you do something different? You want to come show? Come on up. Let's see what you did.
Okay, I just
You know,
do.
you want me to- no.
Let's see if you can get yours together, yeah. You got HDMI. Aaron, come on up, let me see what you got.
Yeah, I should. I didn't know how to do the second part. I just know how to.
Wait, are you want like a graph or something? I didn't draw a graph. I just
No, I
did,
didn't
I just did the formula.
I just want to see how you answered it, because we can just kind of share. This is a little agglomeration, a little knowledge spillover here. Maybe.
Oh, mine just read it out.
So you want to, okay, come on up.
I did. Did it too long. Where do you want it?
Probably right there. I don't know how much room you need, but. And what was the answer?
I got.
Besides, Luke can keep doing this thing. What was the answer, you guys? 22.
So I got this price from total cost, and then you have to divide that by 5 to get how much it would be per form. So that was the cost. C, divide that by 5 to get the price.
Okay. So what's going on with the 5 and stuff? Or who's got questions for Luke? Let me just let you guys ask questions.
Well, I was on the right track.
Okay. So you see how Luke did it, or?
Yeah, I see. I just didn't know that.
Ask Luke.
So you divide by 5, you put up the 5 times, you get the 5 per 5.
Yeah. That's what the 22 is. And then the 5 up here is just because they're all making one product. So each person is making 1, so they make 5 total.
So they try to keep it easy with just the one product with the 5 firms.
Yeah.
And then is it a Nash equilibrium? We could do better if we did it that way. So with one, did you do with one what the price was with one?
I did not, but it would be 70, 5, which would be 14.
Did anybody do that? You did it? If it's one company, if there's 5 companies, and price equals average cost, which is our competition assumption, right? That there's just normal profits, price equals average total cost. And so if one company is in there, then the cost per company on average is 70, price equals average cost, so the market is at 70. And so then the question is, would it be better, what if 2 companies got together? What's our total cost with, it's one company, but 2 units. So this goes up to 60 plus 20 is 80 divided by 2 is 40. Could they be more competitive?
Yeah.
Yes. So then 2 other companies would move, and 1 other company, and eventually we get to maybe 1 company.
So because they do all of that, why does the Nash equilibrium not stable?
Right. Yeah, the Nash equilibrium in terms of the number of firms having 5 firms sustainable in this market isn't stable. I know, you guys got to work together, Don. This is good group work. We'll continue to get a little better as we go through it. Other problems that you want to review? Huh? 5?
Oh, the concept 5?
Yeah. This one? Oops, sorry. So matching, consider a matching model and spatial context workers are uniformly distributed along the roadway. Each firm chooses address along the roadway of unit length and hires 2 workers. The cost of commuting is incorporated into the market wage and times D. So the D is the distance, I believe, right? Where D is the distance from the worker to the nearest firm. Illustrate the determination of the wage in a city with 4 workers, 2 firms, 6 workers, 3 firms. Okay? Let's show the work on that. Everybody's going to show their work eventually. So what do you do? You can kind of talk. Let's start verbally. Who asked the question? Who asked the question? Nate, what'd you do?
I haven't done it yet.
Oh, you haven't done it.
I was looking at it and I was like, man, I figured it out.
Okay.
You start with full fun.
So what did you do, JC?
N is the amount of workers, C sub 4 workers, formula.
For the one that we're given in the book.
Okay.
That's what I did, and then I've got the distance, and then I plug that. That gives you your distance between the firm and the worker. And I plug that into the what D would be. It's basically the same. And
So the distance we had, are you going back to the linear with the fractions and
so
stuff?
the M equals 1/2, whatever that was.
Did you guys do this? Other people?
That's what I did.
If you get a 6,
Yeah, I got 6, and then I times that by the 60 to get the weight.
You gotta keep working, call your friends, phone a friend, do it or start it earlier. You can come and see me during office hours too. So Luke, come on up again. Give you some extra credit today, I guess. Apparently you don't need it if you're solving all these problems. You'll probably be fine without that, but let's not say. Jinx, yeah.
Should I erase this?
Or if you want to go back to you were using the model in the book, right?
Yeah.
So maybe just let's start with that. You went back to the matching model, right?
I didn't use the model helped, but I used the formula that was in the paper.
Okay. You were kind of going off of this conceptually.
Yeah.
Right. Yeah. So we got our distance model, and then we've got the location of the firms at 5/6 and 1/6. Yeah. Okay, and then go ahead. Why don't you can erase that. Could just pull this up. Yep.
So I use this formula to figure out the distance. So we're also given the for the distance. And so the first one we're giving that there's 4 workers, right?
4 workers. Yep. 4 workers. 2 firms.
I did
The M formula was the mismatch, right?
yeah, that's the mismatch. So I just basically made that distance because that's
Which is what they're doing, yeah.
Yeah. And so the weight would be 50 plus the 60 times the 1/6. That gives you 50 10 wages, $60 for the 4.
And that was the answer, right?
Yeah.
So did you guys look at the answer first and then keep working a bunch to try to get to the answer? That's the whole purpose of it,
That's what
right?
I did. Yeah, I just kind of like put it around.
Sometimes you might unpack and start experimenting with a few things. That's what you need to do. Hopefully, at the end of the day, you'll kind of start to have a better understanding of it.
Pretty sure.
So here's the new requirement for all homework moving forward. You are to come to class with your handwritten work. And what we'll do then is you will come up to the document camera and just show what you did.
So we're not gonna submit it on Blackboard?
No, you still gotta submit it on Blackboard, but you gotta do that anyway, and I want you to have it, so instead of doing it digitally, like I mentioned, you could do it by hand, I want you all doing it by hand. Because you guys aren't getting it enough, you're not doing what I want you to, so get it by hand, then I can see your work, and what I did before in previous classes, I actually just graded it on the spot. But I'm still gonna have you take a picture and upload it to the system, so we have it there, because we do need to archive all of our work. But then we can just walk up and say, oh, this is how I did this one. Some of these you're gonna end up, you could do it different ways, or you might have showed it different ways, or whatever. And we'll just kind of share some work that way on some of these tougher problems.
Can we type it out and print it out?
If you want to, yeah. Yeah, as long as you have something here, yeah.
So like,
The only thing I don't like with typing is I don't want people copying. That's why I do handwritten, so.
like if we're typing it, like the formulas out, how, because I just typed out the formula and then plugged it in and then showed each step basically. Is that okay? Or would you rather have it by hand?
I'd rather have it by hand. Because I don't want to get into, hey, what'd you get, and cut and paste, and I'm done with my homework. That's not going to cut it. You need to for the exam. You're never going to make it in class if you try to take shortcuts like that. But if you wanted to, just to answer like a little bit with, there might be pieces of the problem. I just got done having my work study student copy all of the questions and all of the chapters. And it's in a Word document. So I'm going to send the digital version of this to all of you. So then you'll have the digital version of it, and so possibly if there's a picture or something with your handwritten notes, if you want to include it or whatever. I don't really care that much on, you know, some of the static pictures that we use as part of the problem. You could either handwrite your own, which would probably be handy. It gives you a greater understanding of it if you do it that way. But if you wanted to do some combination like that, I don't really care. But once you get into explaining it, having your handwritten work is a lot better. Yeah. Question 3. And we're good on this one then? Okay. Risk neutrality labor pooling. All right, consider the model of labor pooling shown in 4.2. Suppose that the next generation of workers is risk neutral rather than risk averse, with the utility function of utility of income equal to W. So let me just stop right there. If we have a risk neutral situation, if we do U of income minus U minus W, it ends up being a straight line, right? Because before we had the utility of the wage was equal to W raised to the 1/2 power. So now we don't have that. So they're talking about the kind of the difference in the functional form with the risk. For the isolated job is 144, the switching cost is 44. The switching cost is 0 in the jobs cluster. How does the change to risk neutrality affect the advantage of larger cities related to labor pooling? So who got that one? What'd you do? Yeah.
Drew graph.
Drew a graph. What'd you do? Yeah, come on up. Let's see what you got. I don't know if you got your paper or not.
I don't need it.
Okay.
So,
Similar to what you had on that side down there. I had the line going this way, but up here I had the max, minimum, and then the expected
Utilities. Yeah, label your axes, but yeah, utilities.
utility. Sorry for my handwriting stuff. And then down here I had wage. So the minimum, the maximum, and then the expected. So the maximum it says was 144, and the switch cost was 44.
44, yeah.
So that means 144 minus 44 is 100. So that gets your minimum. And so the square root of each of these, the max is 12, because 144 square root is 12.
Yep.
10 square root, 10. So for utility, so then that means that you, I think it says 120. Oh, the answer key had 122 for the expected wage. So the square root of 122 is like 11 point something.
Okay, let me stop you there.
Okay.
So your utility numbers aren't right because you went back to the way, you basically went back to the functional form we used in the problem.
Yeah.
That's where the square root was.
Yeah.
So if that's the function, W minus S, and S is 0, what is this number? What is it? 144. Yeah. So basically it's real simple. Utility equals wage of 144. And now we have it linear, like you have the line. We're down 44, we're at 100. What's this number? 100. So that's your numbers. That's kind of your picture for the switching costs. So then okay, so now your conclusion might be the same. What did you come up with for your conclusion?
That, well, the expected utility was 122. The answer key had that.
Okay.
Or sorry, the expected wage was 122. So then
Now you see why, right?
that, the expected utility would be 1.
Yeah. And so there's no difference between the certain payoff and the uncertain payoff because the person's risk neutral.
I mean, it doesn't have to pay for it.
That means they're willing to take a fair bet.
And then I'm switching up.
So and let me be clear for everybody on this, because some of you can go grab a seat. Thank you. Yep. So a person who's risk neutral is willing to take a risky 144 or a risky 100. They're going to get either one of those two outcomes. We don't know what it's going to be. They're either going to be in the poorhouse or they're going to be filthy rich. And they're willing to take that bet, even, they're indifferent between that and taking 122 for sure. Most people don't behave that way. You'd rather have the sure outcome. So most people are risk averse. They're avoiding risk.
So can you say that one more time?
So a risk neutral person is willing to say, I'm indifferent, I don't care. Give me the risky outcome or the certain outcome with the same payout, expected payout. Because it's 50-50 of getting this outcome or this outcome.
Yeah.
So the expected value of the playing the lottery or playing the game is 122. A risk neutral person says, I don't care. Give me the 122 for sure, or I'll play your stupid game. And I'll either get in the rich house or the poor house. That's a risk neutral person. That's not most people. Most people are risk averse. They avoid risk. Which means that instead of doing this with the W to the 1/2, our answer came out to be 120 or something? 122. Yeah, I guess the numbers were different, right? It was 124 or 122, but let me just pick out a number here. 122, if we had a functional form like this, like the other one was, then this person is willing to take, see how this goes, I almost could have drawn this nicely. If this goes up to here at 120, they get that same expected utility. That's that bowed out part. So most people are risk averse, but they wanted to kind of highlight for you if people were risk neutral, that would be a different outcome.
So risk neutral, you look for the risk, you don't avoid it.
You don't look for the risk, but you're willing to pay the fare. A risk lover is a very unusual person, somewhat insane. Here's what a risk lover would do. You can have 130 for sure, or you can play this game that has an expected value of 122. The risk lover says, let's roll the dice, baby. I just love the thrill of taking on risk, even though it's not a fair bet, right? So their expected value, let me make sure everybody's clear on this, the expected value of playing the lottery with the way we've been doing it is a 50% chance of getting 100 and a 50% chance of getting 144. The answer to that is our 122. So if you played this game, another way to look at it is how much would you be willing to play this game? A risk neutral person would pay $122 to play this game with a chance of winning 144 or winning 100. They would get, so the most that they would lose is $100 or $22 if they lost. That's another way of looking at it is the certainty payoff. But a risk lover would say, I'll pay $130 to play that game, right? Then their odds are not good of winning. So the casinos love to see that person come in, and they do see that person come in. They're usually having an addiction problem or something. Seriously, right? But it's a rare person that's a risk lover. But those are the three possibilities for human beings. You're either a risk lover, risk neutral, or a risk averse. Most human beings are risk averse. It's an irrational love of risk would be the economist's answer back to that. That's where I get into the insanity. You want to take calculated risk to be rich. You don't want to say, I want to be rich, so let's go to the roulette wheel and play. I've got $10,000, I could turn into $100,000. Let's go play roulette to do it. Not a good idea.
I think it's good.
Maybe you better put it somewhere else.
Incorrect, isn't that what you said? Because, for example, I went into Vegas and I was gambling, and I was playing like safe bets and I lost every time. But then the last one I just went all in, I won all my money back and more.
Well, that's just luck.
It can get into, so there's multiple things going on there. If you were just wanting to have fun with the money or whatever, that's different than actually kind of thinking of longer-term wealth building.
Do we do number 17?
Number 17. I think we'll have to do that after class because I want to get to this stuff. Okay, so start bringing your stuff. This will go faster when you guys bring your work to class, right?
Are we turning this in the class problems?
What are your class problems?
Oh, I just assumed that we were doing the class problems.
No, we're not doing any class problems. We're moving on to chapter 5. all just answering your questions. So I'll do this each time. Next time, everybody has their homework in front of them, and we can come to the board and say, oh, yep, this is how I did it. Oh, that makes sense. And we go on. Okay? All right. So, chapter 5, where do cities develop? So this is a little bit shorter chapter. There's basically a couple of little nifty models. So we're going to look at transportation and think about where we locate our company. Should it be near our inputs or near our markets is kind of one of the themes that we're going to do. So if you have an industry where transportation costs represents a large fraction of your business, then you're going to be more sensitive to where you locate, whether you should be closer to your inputs or closer to your market. So here is our kind of 4 categories of things we'll look at. Single transportable output, single transportable input, fixed factor proportions, and fixed prices. So what are these crazy things? So firm fixed quantity of a single product. Firm produces a fixed quantity of a single product as a single transportable output. Right? So then we're just kind of thinking or possibilities of what companies could look like. Transportable input. Firm might have several inputs. All other inputs are ubiquitous. Oh, that again? Everywhere available at a uniform price. So firm may have several inputs, but only one input is transported from an input source. So we'll get into some examples later, so we'll just kind of knock out these definitions here. Firm produces fixed quantity with fixed amounts of each input. So there's one recipe, regardless of the prices. This is probably somewhat an unrealistic assumption, but it helps kind of push our brains one direction. So if we have our output, give me a good, any good.
Corn.
I didn't hear what?
Corn.
Corn, and what was the cake? I heard that first. Cotton candy. Who's that cotton candy all the time? Who's cotton candy lover? Is that Aaron? Sure. I kind of like cotton candy because it is light. That might come in handy later. So let's do cotton candy. So cotton candy is equal to, you got to have 90% sugar, and the recipe is 10%, I don't know, air or something, right? So whatever, our resources are used in fixed proportions, always. So if the point here is that if sugar prices go up, we might want to put more air in, right? So if sugar got more expensive than air, then we might want to say, you know what, we could save some money if we did 87-13 and put a little more fluff into our cotton candy, right? But that's not being allowed to be done with a fixed factor proportions. That's not allowed. Okay, so everybody with me? So they're always going to be fixed, the proportions in which we use the resources. And then finally, fixed prices, kind of taking as given one of our competitive models that it's just, you're a price taker, essentially. All right, so now how do we minimize our transportation costs? So this first example is a resource-oriented firm. Is this firm a weight gainer or a weight loser? We're making bats. So we make baseball bats. What are baseball bats made out of? Wood. At least the professional MLB baseball bats. Wood, right? So we're not doing college ball with aluminum or anything. So we got wood bats. Is this a weight gaining production process or weight losing? Weight losing or weight gaining?
Weight gaining.
Weight gaining? So look at this table here, physical weight in tons.
Is that what it actually means, like weight?
That's what, yeah, so just using the numbers here,
No, you're losing weight.
we're losing weight, so we're turning a big tree into a little bat, right? Now we can talk about the bats being like how many trees does it take to make a bat or a group of bats, right? So not all parts of the tree might not be able to be used or whatever the story is. You know, we have to take off the, we don't use the bark with the tree, right? So the bark of the tree has to be removed. So whatever the story is, as part of our production process, our input is weighing more than our output. Now, that doesn't necessarily mean that our transport costs will be different. So what's the transport cost rate per mile? Which one's more expensive, the bats or the wood? The bats. Why would it be more expensive to ship bats as opposed to trees?
Well, you're shipping
Per unit.
your final product.
Okay, your final product. So what about your final product that would be different than a big old tree?
Those machines.
Yeah, let me go to Seattle here, up in the northwest. What were you got lots of trees, maybe being
Yeah, I was
harvested
gonna
up there.
say a log truck, like there's not much to it. There's a lot of like boxing and like
Yeah.
the trucking.
So the log truck, the big logging trucks. So Zach sees that up in the Seattle area, right? They're just these big, things with a couple things. You just throw, like, if you need to load log or trees, do you really give a damn if you throw them 20 feet and drop them onto a truck? No, you're not being careful with it or anything, right? So all of this stuff can play a role in the cost of the transportation. Whereas when you have your finished product that you're going to try to sell at Walmart, those bats better arrive with the boxes not all dent and dinged, right? Because Walmart's going to send them back. So we have to be careful. So being careful adds a little more cost, perhaps, to the rate. So now we look at the monetary weight. So what is it effectively running us? So for 5 tons of material, it's cheaper, but I had 5 tons of it. So the monetary weight was $5 per ton per mile. Right? Yeah, this is dollars per mile, per ton per mile. And this is the monetary weight here, 1 ton of bats. Yes, it's more expensive per bat, but the total monetary weight ends up being less. Is everybody with us there? Well, how would we put that into a formula? Since we're starting to get a little more comfy, or we need to get more comfy with formulas, what would that look like? How we got to monetary weight.
Weight times transport.
So monetary, let's call it monetary weight. I can't remember if we can do this, but let's go. Monetary weight equals
Physical weight times.
physical weight. Let's call it, I guess, PW
Cost of the transport.
times the transport rate or the wood. Okay, so that's kind of a nice little expression there. And so then we kind of start to depend on which one do we go. And so the monetary weight, and this is the monetary weight for wood. The monetary weight for bats would be the price of the physical weight of the bats. This is the wood times the transportation rate of the bats. Maybe we could do an equation like that, right? That's all we did. We just multiplied the numbers. We do it so quickly, though, sometimes we forget that there's actually a little formula kind of hidden behind there. All right, so now let's go 10 miles. Do we locate ourselves at the input or at the output? So here's our horizontal axis is going from 0 to 10. And let's let X be the distance to the output market. So how many miles is the output market? 10. So here's the input. This is where the trees are located. And here's Louisville Slugger Museum. Right? This is Walmart. I sell the bats at Walmart. So I'm here, and I need to move product this way. Or I have my stuff here, and I have to bring it the other direction, right? So I either have to go one place or the other in terms of where should I locate my bat making production facility. And
Doesn't it depend on the number of bats you're producing?
not in terms of this because we have it on a per bat basis. So our function here is linear up here, right? So we're a certain amount of trees, 5 tons of trees equals X amount of bats or whatever. So that's all going to fluctuate at the same rate, so it's not an issue. Okay, did anybody figure out this graph yet? Now that you've been staring at it, what's going on? Yeah.
What I was thinking was that you would want your input transport cost to be closer to your distributors, like your Walmart, because it's a higher cost
Okay.
to pay for it to travel. But I don't really understand how the graph would portray that.
So let's do another formula here to come up with what our input transfer cost would be. So input transfer cost equals. What would that equal here? Our input transport cost so where is our, judging by this graph here, where are our trees? Where are our trees located at position 10 or position 0, judging by this?
0?
0. Here or this 0?
Left.
The left 0. Our trees are located here. So we can think about the cost of transporting the trees. So what would be the cost of transporting the trees? Using the numbers we had on the last thing here, we had,
It was
what was it, 5 for the trees?
It was, yeah, 5 per.
And this was 1 ton, or no, it was 5 tons, and $1 was the transfer cost, right?
Yeah. And then you have that.
And then we had 1 ton of bats times the transportation cost of 2. So it looks something like that. You got it? Here we go. All right.
Sorry.
A little hot.
Would you end up tying those by your mileage?
So let's kind of ignore the picture for a second and say, if I locate my production facility right where the trees are, I'm in the forest, do I have any transport costs?
No.
No, right? So where is that on this picture?
What is the 0 on the left?
The 0 on the
Right.
left
Right.
or the right? See, we got both places here.
Right.
Right, 0.
What are we measuring along here?
Wait,
Right.
cost.
Money. So, and this is the input transportation cost function, which says as we move this direction, what's happening to the cost?
Goes up.
It's going up, and where is it the highest?
At
50.
At 0. Which means if you locate it here,
You have a higher cost.
are you bringing the trees there, or are you looking at the bats? Are you moving bats, or are you moving trees?
Trees.
Trees. Because what is our cost for the bats?
0.
0.
Yeah, 0.
Output transportation costs. So if I locate my company here, I'm on top of Walmart. So now I make my bats and Walmart's right next door, 0 transportation costs for the output. But I had to bring my trees from the forest. At what rate or at what cost? 5. So I had 10 miles of distance to bring the trees to my output market. 10 miles times 50, because I had $5 transportation costs, was my monetary weight for the wood, was $5 per per unit, per weight, per mile. So every mile I traveled, because I needed to have it with the 5 tons, that's what it took. So 10 miles is going to run me $50. If instead I locate my production facility in the forest, what's my input transportation cost? 0. And what? Now I have to bring my stuff to Walmart. right? So that's going to cost me some money. All right, so where do I want to locate if I'm trying to maximize profits and the price of my bats is located? Would I be wanted to locate here or here? There, here. Right? So we're going to locate where we minimize our costs. So now we see kind of these lines are really representing the differences between moving my output versus moving my input. And I want to pick the least costly thing to do. And using these numbers, then it would be here. This would be the spot to locate.
So the best point for you to be at would be where those lines meet, right?
Here,
No, like the points of the lines.
the points of the lines, yeah.
Yeah, so
Where it's the smallest, though,
Right.
because we're going to minimize costs.
It goes like this.
Okay, questions on that? If you don't quite get it yet, we'll give you another shot here. So now we've got sugar. Now we've got a market-oriented firm. Weight gainer or weight loser? Gainer. So the beverages, after you make the beverages, weigh a lot more, maybe because of the bottling and other things, compared to the sugar. So cost per mile in this example was the same. And so then we've got our monetary weight. And so just looking at that, you can kind of think, well, where would I want to locate?
Be closer to your output.
And if you're thinking, since we just flipped it around, the graph looks different now, right? So now, if we locate here, our total cost, because it's all going to be input cost rather than the output cost. The output cost, if we locate here, we have a lot of money going towards output shipping. And here we've got input shipping that'll be easier. So we're going to locate in the other spot. Okay. Good? Good for today? All right, we'll see you on Friday.